Hello learners and welcome back to my channel TeacherSneha. This is yet another video in the series of videos on simultaneous equations. I have come up here with the third example questions of simultaneous equations solving by elimination method, and as I had already written one example question here on my screen which reads 3x plus 7y is equal to 47, 2x minus y is equal to 3. So these two are my equations, and as I have previously explained in my videos that in elimination method we have to select a variable which is same and then we need to eliminate that variable. But here if we will observe, this is 3x, this is 2x, this is 7y and this is y. So on addition or subtraction of these two equations, there is no variable which will get directly eliminated because their constant values are different. Here the variable x is having constant 3 and 2, and here variable y is having constant 7 and minus 1 respectively. So to eliminate that, what we have to do is we have to turn an equation in such a way that one of the variable have the same constant with it. So to make that happen, I will select this equation number 2 which has a negative 1y or negative y, which I can say. If I turn this negative y to negative 7y, then this positive 7y and negative 7y can get eliminated. So to make that happen, my step number 1 of solving this type of simultaneous equations is multiply equation 2 with 7. So when I multiply equation 2 with 7, I obtain 7 times 2x minus y is equal to 7 times 3. Remember that equation has two sides, left hand side and right hand side. So if I select any number to multiply one of the sides of the equation, I have to ensure that with the same number I multiply the other side of the equation as well. After multiplying both the sides of the equation with 7, what I obtain is 14x minus 7y is equal to 21, and this becomes my equation number 3. Now if you will closely notice equation number 1 and equation number 3, these two equations have a variable plus 7y and minus 7y which can get eliminated if I add these two equations. Step number 2 of this solving of simultaneous equation will turn add equation 1 and 3. So equation 1 had variable 7y, equation 2 had a variable negative 7y. So now we will add these two equations. So 3x plus 7y is equal to 47, and 14x negative 7y is equal to 21. When I will add these two equations, what I'm going to obtain is 3 plus 14 is 17x, 7y and 7y will get eliminated, and this on addition I'm going to get it as 68. So 17 times x is equal to 68. To solve for x, I will shift this 17 to the other side. So 68 divided by 17, x is equal to 4. So this is my solution number 1 which I obtained for one of the variables of the equation. Now I will substitute this value. Substitute x is equal to 4 in one of the equations of your choice. So I'm going to select equation number 2 for that. So substitute x is equal to 4 in equation 2, which reads 2x minus y is equal to 3. I will substitute x as 4. So this is 2 times 4 minus y is equal to 3. 2 times 4 is 8. 8 minus y is equal to 3. Negative y I will shift to the other side, and 3 I will shift to this side. So this positive 3 comes here, becomes negative 3. 8 minus 3 is equal to positive y. Therefore, y is equal to 8 minus 3 is 5. So the answer for the second variable in the equation is y is equal to 5. So the solution for this type of simultaneous equation is x and y is 4 and 5 respectively. If I want to just cross check to find out whether the working that I have done is correct or not, what I do is I substitute these values of x and y in the two equations given. So it is 3x plus 7y. On substitution, I'll get 3 times 4 plus 7 times 5, which is equal to 3 times 4 12, 7 times 5 35, which results into 47, which is given here. And then the next is 2x minus y, which will be 2 times 4 plus 2 times 4 minus 5, which is equal to 8 minus 5, which is equal to 3, which is given here already as an answer. So both the values that I have obtained are satisfying my both of the simultaneous equations that were given, and that is why the solution x is equal to 4 and y is equal to 5 is the perfect solution for these two simultaneous equations. And this was the method involved in solving that. Hope you find my video very helpful in understanding the concept of solving simultaneous equations. Keep watching my channel, and if you like this video, don't forget to give my video a thumbs up. Thank you so much for watching. Stay tuned on TeacherSneha.